Let's learn how to find derivatives of polynomials with clear examples. The power rule is the fundamental tool for finding polynomial derivatives. We multiply by the exponent and reduce the power by 1. The power rule is the foundation for differentiating polynomials. The derivative of x to the n equals n times x to the n minus 1. Simply multiply by the current exponent, then reduce that exponent by 1. For example, the derivative of x cubed equals 3x squared. The derivative of x to the fifth equals 5x to the fourth. When coefficients are involved, we apply the constant multiple rule. The derivative of a constant times a function equals the constant times the derivative of the function. The coefficient remains unchanged while we apply the power rule to the variable part. The derivative of 4x cubed equals 4 times 3x squared, which is 12x squared. The derivative of 7x to the fourth equals 28x cubed. For polynomials with multiple terms, we use the sum rule. The derivative of a sum equals the sum of the derivatives. We can differentiate each term independently and add the results. Let's find the derivative of x cubed plus 2x squared plus 5x. The derivative is 3x squared plus 4x plus 5. Let's work through a complete example step by step. Find the derivative of 3x to the fourth minus 5x squared plus 2x minus 7. We differentiate each term separately. The first term gives 12x cubed. The second gives negative 10x. The third gives 2. The constant derivative is 0. Combining all terms, the derivative is 12x cubed minus 10x plus 2. Let's try a more challenging polynomial. Find the derivative of 2x to the fifth plus 6x cubed minus 4x squared plus 9x minus 1. We apply the power rule to each term systematically. The derivative of 2x to the fifth is 10x to the fourth. The derivative of 6x cubed is 18x squared. The derivative of negative 4x squared is negative 8x. The derivative of 9x is 9. The derivative of the constant negative 1 is 0. The final derivative is 10x to the fourth plus 18x squared minus 8x plus 9. Now let's find a derivative and evaluate it at a specific point. Consider h of x equals x cubed minus 6x squared plus 9x. The derivative is 3x squared minus 12x plus 9. Let's evaluate this derivative at x equals 2. Substituting 2 for x, we get 3 times 2 squared minus 12 times 2 plus 9. This simplifies to 3 times 4 minus 24 plus 9, which equals 12 minus 24 plus 9, giving us negative 3. Let's look at some special cases to remember. The derivative of any constant is always 0. The derivative of x is simply 1. This follows from the power rule since x to the first becomes 1 times x to the 0, which is 1. Let's review the key concepts. Remember the power rule. Multiply by the exponent and reduce the power by 1. For coefficients, keep them and apply the power rule to the variable part. For multiple terms, differentiate each one separately and combine. Always remember that the derivative of any constant is 0.